Hi, so we've worked with quadratic functions a couple of lessons now, and I've given you this overview to sort of summarize the most important things you need to know by now. And this is just a one sheet sort of cheat sheet, and you need to notice that a is not 0 in every formula on this page, because if a was 0 in this quadratic function, then you wouldn't have the quadratic term, because 0 times x squared would be 0. And then it would revert back to being a linear function, which is not a quadratic function. So this is our prerequisite. Anyway, we have these quadratic functions in different forms. We have the general form, which is when it's given as ax squared plus bx plus c, which is the normal form. That's the one you're going to see the most. And some things you should know about that one is we have the graphs, and I've tried to illustrate how they work. For a, if it's positive or negative, that tells us whether the parabola is like a happy face or a sad face, if it points upwards or downwards. And one more thing, there wasn't room for that, but the larger the a value is, the more narrow it's going to be, and the closer to 0 it is, the more wide it's going to be. And that's true for both the positive and negative cases. The c value is easy, that's just where it intersects the y-axis. So if c is 5, then it's going to hit the y-axis at 5. If c is negative 17, then it's going to hit at negative 17. The b value is a bit technical. The b value is at the point where the graph crosses the y-axis. So the point where it intersects. The question is if it is increasing or decreasing. So if b is a positive number, then when I go from left to right, I'm going to go upwards. If b is a negative number, if I go from left to right, at that point where it crosses the y-axis, it's going to go downwards, the graph. If b is 0, then I'm at the vertex, because then I'm neither going up or down. That's the point where it turns. Last but not least is I have the discriminant, which the formula is down here, which is going to be relevant. And we have three cases. Either it is positive, which is the same as having 2 roots. It's 0, which is the same as having 1 root, so the vertex is the root. Or if the discriminant is negative, then it does not hit the x-axis at all, so there's no roots. If I need to solve exercises, I can be asked for different things. I could be asked for the x-intercepts, so that would be these roots. If I were to do that, then I know that y is 0, so I need to solve this equation. And the way I do that is this box. I calculate the discriminant first, and then I use the quadratic formula afterwards. If I want to find the y-intercept, that's easy. That's just the c value. That's what I set up here. If c was 7, then it intersects at 7. So that's easy. The axis of symmetry, which is the vertical line going down through the vertex, is given by this formula. X is negative b over 2a. So this was the general form. Now we have two more forms. We have the vertex form, which is if I know the vertex coordinates or I need to find the vertex coordinates, this can be useful. And I have the factorized form, which can be useful if I know the roots. So I'm going to go through one at a time of those. The vertex form. The vertex in this form has coordinates h, k, and these two x and y coordinates come into the formula as this h here and this k up here. And the a value, that's just the same as you had from the general form. So that's whether it points upwards or downwards and stuff like that. Notice that this formula for the axis of symmetry can be used as the same, and it goes through the vertex. If I want to find x-intercepts, then I need to solve this equation. Down here I need to set y equal to 0, and I need to set up this equation. And I can solve that. Or I can expand the brackets, and then I can solve it the way I did the general form up above. If I need to find a y-intercept, I need to calculate what happens when x is 0. And if x is 0, then I substitute x in for 0 in for x, of course, and then I calculate whatever my y value is going to be with the given numbers. Axis of symmetry is easy, because if I know the vertex x, y, then the axis of symmetry is just the y coordinate, right? X coordinate. Whatever. So if the vertex, let's say this was 5, 1, well then the axis of symmetry would be x equal to 5. So that's easy. The factorized form. last but not least is if I know the roots, and I've called them alpha and beta, so these occur in the formula up here. Now, if I want to find the x-intercepts, that's easy. That's just the alpha and beta values. So that's the nice part about this. If I know the roots, then I have the roots. If I want to find the y-intercept, again, I know that x needs to be 0, so I need to calculate what happens if all my x's are replaced by 0. And then I calculate whatever y this is going to give me with the given numbers. Axis of symmetry is symmetrical in the case that the roots are equal length to the left and right. So if I know the two roots, what I do is I add them and divide by 2. So I take the average or the mean of them, and that's going to be the axis of symmetry. So if this was 1 and 5, then x would be equal to 3 if I wanted the axis of symmetry, for instance. Because 1 plus 5 is 6, divided by 2 would be 3. And that's what you need to know. Have fun.